to the second session of the NLP crash course. So while the remaining participants are joining us, I want to say a few words about this general format. So the NLP crash course is a series of talks organized by SwissNLP, so the Association for Natural Language Processing in Switzerland. And this year, SwissNLP is organizing the SwissNLP Days. So let me tell you what the SwissNLP Days are. So I hope you can see my slides. The SwissNLP Days extend over 3 days in May. They take place in Winterthur, Switzerland. And it's an event that's all around AI and natural language processing. So there are 3 elements of the SwissNLP Days. The crash course, that's what's happening today. On the 13th of May, there will be an exposition. So this is especially interesting for companies that are either offering products in the area of natural language processing or that are interested in talking to people who are offering such products. And academic exhibitors will also be present, like the University of Zurich, the Zurich University of Applied Sciences, and many other universities in Switzerland. And finally, on the 14th and 15th of May, the yearly Swiss Text Conference will take place, which is especially interesting for NLP professionals and scientists. So with that, I want to introduce today's speaker. It's Professor Rico Sennrich. He's from the University of Zurich, professor for computational linguistics, and he's going to talk about the sudden success of generative AI and large language models. So Rico, would you like to share your screen?
Yes, thank you, Yanis, for this introduction. So is screen sharing working okay?
Yes, so I think your talk is going to be around 30 minutes. So this will leave us enough time also to then have a discussion and to answer any questions participants might have, either in the chat or by speaking up. Okay, Rico, the floor is yours.
Okay, thank you. So thanks, everybody. So in the next 30 minutes, I hope to give you a bit of a very small crash course, very short, to give you a bit of technical background to understand what's under the hood of a lot of generative AI, especially large language models, and what were the key elements that helped turn this from something that's been a long-term research field to something that's now commercially usable for various applications. Yanis already mentioned I'm now a professor at the University of Zurich. Just a bit of background, I actually did my PhD in Zurich as well, about 25 years ago. You can see we were a small group at the time. I then moved to Edinburgh, where I was 6 years in different functions. Bit of a larger group, one of the largest research groups on natural language processing. And now I'm back in Zurich, and our group in the meantime has also grown, which is also a sign of the success of this research field. So I like to start with something very simple and something very old. So Claude Shannon, around 70 years ago, he tried to measure the entropy of English. And to do that, he asked human participants to guess what is the next letter in a text. And you can play this along. It doesn't really work in this remote setting very well. So just imagine that you're now guessing the first letter in some text, for example, T. And then you can guess the second letter. Maybe you're right, it's H. The next letter. Maybe you're right, maybe you're wrong. E happens to be the next one, then space. Maybe a bit harder to guess what comes next. So the annotator in this experiment actually was wrong. He or she guessed R, and then O, so guess something else, then R is actually the right one. Then O would come next, and again an O. And then the human participant was actually guessing right again with room. And we can go on, and you can actually see there is some red in this guessing, but a lot of black as well, especially towards the end of the word. It's very easy to guess what comes next. Function words are often guessed right. And Claude Shannon used this to say, oh, there's actually some redundancy in language. So the entropy of language is not, that is actually also what allows us to compress text. Not every letter is really needed to encode a message because we are using our knowledge of the statistics of language, what words exist, what words don't exist, what is grammatically possible, what isn't. What are some frequent idioms or cliches? And you use this knowledge all the time. So you use this for proofreading. If we're having a conversation, you might be able to say, to guess what I will say next, and so on and so forth. And I want to make the point that this actually goes beyond just knowledge about language. Yes, there is knowledge about language. Like if you see a Q, the next letter is probably U. If you see a subject in English, probably what comes next is a verb. But there's also knowledge about the world encoded here. So if I see dogs, then I'm guessing it's more likely that barking comes next. If I see a cat in a text, it's more likely that meowing comes next. You even need to do maths to be able to do this guessing game. If I say a man has 5 apples and he gives away 3, then he has 2 apples, right? So you do math to do this guessing game. Ilya Sutskever has this famous example saying, imagine you're reading a detective novel and you're playing this guessing game all the time. And then on the last page, the detective says, and because of all the evidence, I know that the murderer is, and then guess the next word, which is the name of the murderer. And to really play this guessing game right, you have to understand the novel. You have to understand who are the people and what evidence is presented and so on and so forth. So there's a lot of skill involved in this guessing game. And what we actually do in natural language processing is that we don't just try to estimate how good humans are at this game. We build statistical models and machine learning models that try to actually play this game for us. And if you do have that you can use it for various applications. You can, of course, autocomplete on the phone. It's basically a direct application. But you can also turn something like translation into a guessing game where you say, I have a source sentence, the dog barks. I have some indication that I want a translation, and then I produce the translation one word at a time or one letter at a time. That way, model that can play the guessing game can translate or can do grammatical error correction, or it can write me a Shakespearean poem that describes the physics behind climate change. And you can try this with your favorite chatbot, and it's actually surprisingly good what comes out with this, with many chatbots. So how do these models look? Well, in Claude Shannon, the language models looked a bit like this. So this is basically just a table of letters, and you say if the last letter I saw was Q, then these are the probabilities based just from counting what comes after. So in English, after Q, like in 98%, U comes next. And then you can play this for every character in your alphabet and get some statistics, and then you guess the most frequent one. And if that's wrong, you go with the next frequent. Now, this is not a very strong language model because, yeah, for Q, it's very easy to decide, but there's a lot of wrong decisions you will make. And you can now improve these language models by saying, okay, maybe if we don't just consider the last letter, but a few letters, we have more context, we will be better at this. And this is how, like, for 50 years, people improve these models using more context, using larger units, words instead of letters. But we reached some limits because it was hard to really generalize well for sequences we haven't seen. And so in the last couple of decades, language models have really moved over from just counting frequencies to representing text as a point in vector space. And you can see this in the left here, what I try to indicate, where you're trying to represent the text that has come so far as a point in a vector space, where you can then draw a simple decision saying, if your point in vector space of the text so far is on one side, then the next word is likely meowing. And if it's on the other side, the next word is likely barking. So dog, the dog in the pet store might be a sequence you've never seen during training. But as long as you can represent it to be that the dog in the pet store that's similar to just the dog, you can still make the right prediction. Now, we can't just store all of these representations of every conceivable text, even text that we haven't seen before, in this space. But what you can do is to build a representation step by step, and that's what I'm trying to very simply sketch here on the right, where you have some representation of the individual words, and then from these representations, you build up representations of the larger units of text. And this is basically what a neural network does for us. So neural networks are some kind of mathematical function, and they are much more complicated than this. That from the individual inputs and some internal parameters of the function build up the representations from which we then make the prediction about what comes next. Now, we had some breakthroughs about a decade ago. For example, I said now we are predicting the next word, but it turns out the vocabulary is actually quite large in most languages. We're talking about millions of possible words. We can't really learn representations of all of them. That becomes computation very expensive. It also doesn't generalize very well. Imagine you've now trained your model and suddenly the corona pandemic happens and you want to be able to translate the concept of Corona-Pandemie-Maßnahmen-Gegner into English. So opponents of the corona pandemic measures. If you've never seen this word before during training, how can you still be able to translate it? Well, we could do letter-based modeling, but then your sequences become very long. It's very inefficient. But if you do something in between, some so-called subword units, this actually works surprisingly well. I like to mention this because this was one of my contributions to large language models still in use in models like ChatGPT and this breakup. Another breakthrough was to have a strong model that can also learn relationships across long distances. This is illustrated here. An Indian man who was convicted for killing his wife by making a cobra bite her has been punished. So if you're predicting the verb here, he has been punished, you need to know what the subject is, but the subject can be far away. It can be an Indian man here at the very beginning. But it turns out there's a type of neural architecture that's called attention model. You might have heard of the transformer that is based on this attention model that can model this very well and learn this very well. So natural language processing language models nowadays are typically based on these subword units and transformers. And in the last 5 years or so, a lot of the development has happened by making these models larger in terms of the amount of text that they see during training, larger in terms of the number of parameters that you can learn in these neural networks. So you can see from like BERT 2018, we go from a few 100 million parameters to now a few 100,000 million parameters in the latest models coming out last year. Training costs have also exploded from like a few hundred or few thousand francs in cost, just in terms of compute to train these, to tens or hundreds of millions of francs or dollars. But it turns out a lot of these things were necessary because when people like this, it comes from 6 years ago, people were talking about the possibility of asking a language model questions about the world and getting answers there. And then on Twitter, people made fun of that. Well, if I want to find out if I just have a prompt, a cat has 4, and I let the language model at the time, GPT-2, complete it, it just says a cat has 4 kidneys, 2 small ones, one giant one on top, one in the lower back, and one in the tail. And you can try this with a modern model and it will not make these silly mistakes. It will give you a good answer. So a lot of that just came from the huge scale, the huge amount of text these are trained on, the huge number of parameters which actually allow it to encode in the parameters of the models a lot of knowledge about the world. There were other ingredients that were necessary for language models to really have a breakthrough. Microsoft launched a language model in 2016 called Tay. I think they had to take it down at after 24 hours because the problem was you could ask it things like, do you support genocide? And then Tay replied, yes, I do indeed. Or what race genocide? Well, you know me, Mexicans. I mean, this is completely racist, completely inappropriate, a huge PR nightmare here for Microsoft, so they took it down. So what language models nowadays do, and ChatGPT was the first one to do this, to the be public facing. Not just are they much larger in size than earlier models, but they also have, in addition to just training, learning to predict the next word in the text, they do this on specific dialogues that were created by the company here, OpenAI, that show the intended mode of interaction. So you want a model to refuse certain answers because, or refuse to be racist because that's just not, there's potential harms in there in doing that. They do that in two ways. You can just do the normal training. The normal training here is just learn to predict the next word, or you can do something like with reinforcement learning. Here's this motivation of this instruction tuning saying, okay, this is some kind of alignment with also human values. We want the language models to be helpful, we want them to be honest, and we want them to be harmless. So this is something you can easily see this behavior if you ask language models nowadays, how do I create napalm? It might refuse. So this is not some kind of language model that now knows about itself. This is it has been trained that this is a probable response given the query. What it does better than previous chatbots is that it's much more generalizable. Like previously, we may have had chatbots that had like regular expressions, and then if you match a regular expression of a question, you give the answer. Here you can actually learn about what are similar types of questions, and then if it has learned to refuse to answer for one question, plus also have learned to refuse for a paraphrase of this question. There's other advantages of this instruction tuning that made this language model much easier to use. So previously with language models, you wanted to extract knowledge from it, like what is the capital of Belgium? You had the problem that there's lots of probable continuations of this text. If I say the capital of Belgium is, and then I say, please complete this, it could just say, oh, it's a nice city. And then people were developing tricks to actually get the output that they want. So if I'm interested in capitals, maybe I start a list and say the capital of France is Paris, the capital of Switzerland is Bern, and then the capital of Belgium is, and then please continue. And then it's much more likely to actually respond with the actual answer with the capital than with some random other fact about the capital. So this prompting was really important for language models to get the output you want. And it is still important, but it's less important now with this instruction tuned models, because I can just say, what is the capital of Belgium? And it will say, well, the capital of Belgium is Brussels. If I use this with a language model that wasn't instruction tuned, I might not get an answer. I might get, it might continue the text as if this was a rhetorical question. What is the capital of Belgium? Many people, or how should I know? Or something like that. Or, and that was the question in the test and I got the question wrong. Or some other fictional completion. Now with ChatGPT, you get this better. So what are the ingredients we talked about now? We talked about large models. We talked about this instruction tuning. There's also the reinforcement learning. So the standard instruction tuning is basically just training to predict, training the probability of the next word in these human written chatbot interactions. But maybe you have some other sources of knowledge you want to consider. For example, what if you have some outputs that you know that are bad? You could also want to directly penalize them rather than just giving good examples and rewarding the good examples. Or maybe you have, maybe rather than having a human write some dialogue, you have some actual dialogues of a user and the language models, and you just want to very quickly rate them, have a human say, oh, this is a better answer than this one. And then there's a lot of algorithms have come out in the last couple of years that basically do the same thing, that they take these types of rankings and try to turn this into train better models from them. For some tasks, like if you have a reasoning task where you have some kind of mathematical question, it might actually also be, you might also be able to automatically say, is the answer correct or not? Because the answer is just a number that you can simply match with the true answer. So then you can actually also automatically say, oh, this is a right answer and this is a wrong answer, and then try to improve the probability that the model produces the right answers over the wrong answers. And so there's a lot of development now happening with reinforcement learning. What might be useful for you to know if you're intending to use language models for something, if you want to launch a product with language models, probably the most important thing for you is how do I interact with language models? What kind of prompts can I use? And I already showed you this type of prompting where you create a list with examples before instead of just asking the question. I said it's no longer strictly necessary with something like ChatGPT, but for many applications, it's still an important way of boosting the quality. So you can boost the quality of lots of applications by showing it some demonstrations of inputs and good answers. And you can just add these to the prompt, and then I have the final prompt where you want to see the output. There's other types of prompts that have been shown to be relatively universally useful. So for example, if I ask a ChatGPT how many, this is an older version, how many prime numbers are between 70 and 80? I might get some hallucinations. There's only one prime number between 70 and 80, and that is 73. This is wrong. If I just add one bit to my prompt and say, let's think step by step, the answer is completely different. Why is it completely different? Well, these are the types of questions where it's unlikely that the question and the correct answer have been seen next to each other in the training data. So it actually needs multiple steps to solve these questions. And the models are not, because of the way they do next word predictions, they don't really do this computation of these multiple steps internally before they predict the next word. But if you explicitly tell them before you give the final answer, tell me the steps in between, then the output might be something like this. To find prime numbers between 70 and 80, let's think step by step. Start with the first number, which is 70, check if it's a prime number, then move to the next number, check if it's a prime number, move on, and so forth, and so forth. And then it goes through the list and says 71 is prime, 73 is prime, and 79 is prime. So among the numbers, the prime numbers are 71, 73, and 79. So there are three prime numbers between 70 and 80. So this kind of chain of thought prompting for a lot of reasoning tasks has become a very useful boost for the models. Another thing that has exploded in the last year to give you new ways of interacting with the language models is what we call retrieval augmented generation. And I'm starting with a very simple example. Let's imagine I want to do machine translation. And I said before now, this giving examples can be helpful. So we also call this in-context learning. Now, I could have random examples of some input text and translations that I give the model. But I could also say, if I want to translate some sentence into, let's say, from English into Romansh, maybe I want to have some similar English. I can find some similar English sentences with Romansh translation in some database I have. And if I pick the similar ones, then this is more useful for the model. The model will learn more from them. So I now have two steps. I have the first prompt, then I have some retrieval in some database, and then I turn whatever I retrieve into the prompt. Now I can do this for translation, but this is very flexible, and you can do this, for example, if I have questions about recent news, I can have a setup. I have the original query. How do you evaluate the fact that OpenAI CEO Sam Altman went through a sudden dismissal and then was rehired? And the normal language model that was trained on text that was a year old might not know anything about this and will just say, I am unable to provide comments on future events. But what you can do instead is to have a combination of a language model and a search engine. And then you first search for relevant documents about the dismissal of Sam Altman. and you find these, and then you have 3 news stories or something, and then you create a new prompt and say, this is the original question, and then please answer the question based on the following information, and then I'm adding the newspaper articles about Sam Altman to the prompt. And then it's basically becoming a summarization task that the model now has to, based on the original query and this information, just extract the relevant information. That's a much simpler task. It doesn't need to be, the information doesn't need to be encoded in the language model. You can update this very quickly, this information, because it's updated as quickly as you can update the search engine. So you can see, if you do some thinking about this, you can see the potential in this retrieval augmented generation, because it doesn't need to be a search engine on the web. It could be some company internal data that you search. It could be any kind of database that is relevant to you, that you also use as an additional knowledge source for the generation of the answer. So when I set the title few weeks or months ago, I said, oh, the sudden success of large language models, and I was thinking of ChatGPT as being this sudden success story. But you might have heard in the news that now there's this new model, DeepSeek R1, that a lot of companies are excited about or worried about, depending on where you are. And I just wanted to say a few words what's happening there. It's not, again, maybe from the point of research, there's not this sudden explosion in performance happening. So one of the things that DeepSeek does is it's starting with this chain of thought idea, which even without training, it kind of works. But you can actually explicitly train the model, even if it's not part of your prompt, to do a chain of thought internally, and whatever question comes, first produce a long text thinking about the individual steps, and then produce the final answer. And for some types of tasks, these reasoning tasks, this is quite an effective strategy. I mean, OpenAI now also has a model which does this reasoning internally. O1, they just released O3, which does the same thing. Just to show the same example as before, how many prime numbers are between 70 and 80, this DeepSeek model is really, really chatty, but it basically does the same thing, goes through this list and checks for each number. Is it prime or not? And then in the very end, it says, thus, there are 3 prime numbers in this range. So why are people excited? Well, one of the reasons people are excited that there's now this relatively unknown company that on this reasoning task, which is one of the most prestigious tasks right now in large language modeling because it's so hard, is comparable to the leading models of OpenAI. That doesn't mean that this is now, as a general model, the best model to use, because it might be much worse in other aspects. If you're caring about some other languages other than English or Chinese, might not give you the best mileage there. There's other models trained for specific data to be especially good on this type of data. OpenAI now is this DeepSeek model R1 is trained to be especially good on reasoning. But one of the other reasons it's upsetting is that the cost of using this model is relatively low. You talk a bit about the low training cost. Maybe you have to take that with a grain of salt. There's probably a lot of development cost that is not in there, a lot of manpower went in there. But still, it's exciting for us that the cost of also of these high-performing models is going down. It's exciting for us as users of large language models, of maybe people wanting to build a product on top of large language models. It's maybe less exciting and more of a danger, of a threat to the established players who sell large language model compute like OpenAI. But it's actually continuing a trend that has started far before DeepSeek, that there are models that are closed, like OpenAI, despite the name very closed. And there is a lot of open source models from different companies that are more and more approaching the closed source models in performance. You can now actually download these models, run them locally on your machine, which is also very interesting if you're dealing with any kind of confidential, sensitive data that you don't want to trust to the web, to some other companies, send this away. You can run the model internally in your company and make sure that data stays protected. So that's it for this quick crash course in what are the ingredients that are really contributing to this performance of like generative AI and large language models specifically. So we have now massive amounts of training data. I think Meta was just in a lawsuit. It was discovered they actually pirated the 82 terabytes of books to train the Meta model, to train the Llama models. So massive amounts of data, different tasks, from predicting math tasks to detective novels. We have powerful neural architectures called the transformers, which do this next word prediction task very well. And then we have some strategies that you do after the initial training to achieve this alignment with actually what is useful and harmless for humans. And then after the models are then finally trained, you as a user or developer, product designer, you can have a lot of freedom to design prompts that are suitable for the task that you're interested in. And this might also involve some retrieval augmentation. So like Yannis said in the beginning, there will be a lot of stands, research institutes, companies talking about their research and products at SwissNLP Days. So please come there and join us to learn more about this. I also want to mention, if you want to do something more intense, we also have a certificate of advanced studies. This is a 10-day course at the University of Zurich on generative AI, covering language models, but also other modalities. So thank you for your attention, and I'm now here for questions.
Yeah, thank you very much, Rico, for this really crash course, very deep. I think on a level of depth that many people probably didn't hear from the media. So as people are typing their questions in the chat, I want to raise attention for the next crash course section. So this is happening in 2 weeks. I'm sharing the QR code where you can sign up via a Google form. So the next session is in 2 weeks. The title is ChatGPT, Tips and Tricks. So we're moving from the scientific perspective to a very applied perspective. We'll have 3 exciting speakers from the industry, so from different industries like media or consulting, and they're sharing their practical experiences with using ChatGPT for their profession. So take the opportunity, scan the QR code, and register for this next free session of our NLP crash course. So let's see if there's any questions that people would like to ask Rico.
Some trouble seeing the chat, so I stopped sharing for now, but
there's a question from...
I can also start this again.
Yeah,
sorry.
I'm going to read it. So there's a question from Ignacio. He said, Rico, you talked about ethics. I personally believe it would make more sense to make the bias transparent rather than trying to be ethical. What do you think about that?
I mean, if you don't do anything about trying to make like the outputs more useful, you will end up with something like, I mean, it's not just, when I talk about ethics, I don't just talk about bias, I also talk about dangerous things. I don't want the model to make it easy to give instructions how to perform a crime. I don't want the model to start insulting me as a user. I want it to be helpful and try to actually answer my questions. So this is a lot of what the instruction tuning does. Now, when it comes to biases in terms of like maybe you have some tendencies that it makes decisions based on like stereotypical decisions rather than actually being very logical about this. These biases, it is good to make these transparent, and we have seen for specific applications that this is being done. Like if you have a machine translation task and you have a doctor in English translate this into German, some systems now say, oh, it's actually not specified whether the doctor, male doctor, female doctor, but for translating into German, I need to specify it because I need to decide between Arzt and Ärztin, and it's great to actually show both options. And I don't know what it means here to try to be unbiased, because neither of the options, and just producing only Arzt or only Ärztin, neither of these would be completely unbiased. Just flipping a coin and sometimes saying one, sometimes the other is also not very useful for users. So yes, it's great if you have these cases where there's things that there are actually decisions to be made, and the machine then doesn't try to make one decision that is fair, but there's actually multiple options, and please, as a user, you look at this and you make then the final decision.
So there's another question in the chat from Jimena. She's asking, it seems that the current trend is very focused on post-training strategies, for example, in-context learning. Can this be considered learning, since the traditional concept of learning in machine learning involved parameters update, gradient descent, etc.?
Right. I mean, in context learning is like one specific strategy. A lot of these post-training strategies still involve parameter update or gradient descent, so something like instruction tuning or reinforcement learning is still learning in the classical sense. Now, this in context learning, this is what I showed you with this example, but like I'm giving a list, the capital of Paris is, the capital of France is Paris, the capital of Belgium is, please continue. And yes, I also have a bit of a problem with calling this learning, because the model doesn't doesn't learn in the sense that there's any changes to the internal state of the model, in the sense that it has now acquired some new skill that it retains, but it's just basically it's doing this pattern matching for the specific example, and you're helping basically the pattern matching capability along by showing it the pattern that you want to see. And then you're basically making the task easier with the current pattern matching abilities. It will make it easier to give the result that is useful to you. I hope this answers your question.
Okay, so I see that among the participants, there are also people from the industry or from institutions that are not research institutions. So I also want to give you the opportunity to ask me maybe more practically minded questions.
This is Martin. I don't know if you can hear me.
Yes,
Yes.
I can hear you.
Yeah, maybe this is not a use case question, but I think I was more wondering, let's say, what the future brings. So we have DeepSeek, which is a really high performing reasoning model, and it's been trained on less resources with less cost. And Rico, you also presented the chain of thoughts and other concepts and methods that these models are using. But from research perspective, what are like the next technology steps that you think are in these new models? Or what are we going to do that this curve that you've shown before is not sort of fading out, but goes into the next level?
Right. I mean, I think a lot of the potential we haven't used yet comes to different modalities. So, I mean, text is a very traditional application now, that a lot of these models are text-based, but you have seen some multimodal models already that can generate images from text, or that can describe an image in text. But there is a lot of challenges there still to even go like to something like videos. We're now also researching the art department, doing like something like working with sign language, where you have a completely different modality. You have the video that is your input and that you want to translate. So we have seen that we are still very much in the infancy there, partially because of the maybe lack of data, partially because it is also challenging to work with these modalities. There's lots of languages that we haven't really made much progress in because these models are very data hungry. They do have this interesting property that if you learn something for English, you can transfer the capabilities to some extent also to other languages it has been trained on. But we are still talking about maybe a few dozen languages where these models work well out of the thousands of languages in the world. So these are some of the directions I think a lot of more work needs to be done to really unlock the potential for them. Maybe not visible in this in these benchmarks that are focused like on English text processing, and I'm not sure if English text processing is the type of task where you can expect the biggest jumps in the near future.
Okay, thanks.
So there's two more questions in the chat. I'm going to read the first one by Francesca. When models are trained using reinforcement learning, are they still learning to predict the most likely next word, or is there something fundamentally different happening?
So what they're doing at test time, we call it test time, when they're being used, they're still being used the same way, that they produce one word at a time, and that it then, based on the probability of the next word, it picks what to do. But what can happen is that we are not, it's no longer trained towards producing human-like text that is useful. So this is also what like this OpenAI O1 model, they actually hide the chain of thought from the user because a lot of that is no longer interpretable, because the reward comes from having the result in the end right, and it can actually turn out that you can improve on that final reward that you do with reinforcement learning, even if you produce a chain of thought that is no longer, doesn't necessarily make sense to a human reader. So this is where this may be diverging from like producing probable sequences of text, that this is no longer enforced in this reinforcement learning, but it's still doing next word prediction internally.
Then a question from Gabriel. You mentioned that the LLMs are more accessible now to deploy locally. Since most of the LLMs are still quite large, requiring large GPUs, often in practice people stick with BERT models coupled with fine-tuning on internal data. Recently, the new modern BERT has been released. Do you have already some experience with it? Is it the new go-to model for local usage, or would any of the smaller llama models still be preferable for simple tasks such as similarity, retrieval, classification?
I don't have experience with modern BERT. I can say there's actually a fundamental distinction between like BERT and generative models, and that BERT has been trained in a way that it actually sees all the text except for a specific word and then tries to predict that word that has been masked. So these models, they're great if you do some kind of, and then what they do internally is they build a representation of that word for the prediction. So what they're great at is they have good internal representations of the different words or subwords that you can then use for something like token level classification, but you cannot use them to actually generate, or you cannot easily use them to generate the new text. So that's one of the main distinctions from the new generative models like Llama, etc. And it really depends on your use case, whether you want a model that is able to generate some answer, or you want a model that has good representations of each position, where you can then fine-tune the model on some data that you have. And I do tell my students also, if it's a token level task, you're interested in some token level classification, there's actually something to be said for these BERT style way of training models, because you get it has some complicated reasons that are hard to convey in this short time, but it has to do with, if you do next word prediction, actually having a good representation of the current word is not that important, because sometimes it doesn't matter for predicting the next word what the current word is. But if you just try to mask the current word and then predict it again, you have to build a good representation of that position. So it's different qualities of what is being represented internally in these types of models. So depending on the task, I would recommend to use one or the other. And it's not, this isn't an argument about size. So you first have to decide whether you want to have this bird-style masked language model or whether you want to have a generative model, and then you can see what size you can, that is useful for you and you can work with.
Who would like to ask the last question of today's session? No one? All right, so it seems like people have been able to ask all the questions that they wanted to ask. So again, thank you very much, Rico, for this nice introduction into LLMs and generative AI.
Thank you, everyone. Oh,
yeah, so let me share again the QR code quickly for the next session, ChatGPT tips and tricks. So please sign up and I will send you the Zoom link to participate in 2 weeks. All right. Thanks
everyone.
and
Bye.
see you in 2 weeks. Bye-bye.
Bye, everybody.